Hello everybody. So in this video I'm going to show you how to model motion using first order differential equations. So in example 1 we're told that a particle Q is moving along the x-axis and at time t seconds Q has a velocity of v meters per second in the direction of increasing x and an acceleration given by this function here. And when t equals 0, Q is at the origin and moving with a velocity of 10 meters per second in the direction of increasing x. And we've been asked to begin by finding the velocity in terms of time. So with questions like this, the best thing to do is to start by drawing a diagram. So we have our x-axis, and we're told that when t equals 0, Q is at the origin. So we'll say this bit is the origin, and here's Q. And at the origin, we have t equals 0, and we're also told that Q is passing through with a velocity of 10 meters per second. So v, which is also dx by dt, is equal to 10. And because Q is at the origin at this point, we also know the displacement is 0. So now we need to use the acceleration function to work out the velocity. But we know that acceleration is the rate of change of velocity, which is dv by dt. So if we took the integral of dv by dt with respect to t, then these dt's would cancel, and the integral and the derivative would cancel, so we're left with v. So to work out the velocity as a function of time, we need to integrate the acceleration with respect to time. So this will be the integral of negative 2e to the negative 0.1t dt. And we can integrate this using the reverse chain rule, where we multiply this negative 2 by negative 10. So this becomes 20e to the negative 0.1t plus the constant of integration. And we know that when time equals 0, the velocity equals 10. So we can substitute these two boundary conditions into here to work out the constant. So 10 will equal 20 times e to the 0, because 0.1 times 0 is 0, plus the constant. E to the 0 is 1, so 10 will equal 20 plus the constant, so therefore the constant will equal negative 10. And now we can substitute this value back into v. So the velocity as a function of time is 20e to the negative 0.1t minus 10. Okay? So now for part B, find the maximum value of x, and x is the displacement, attained by Q during its motion. So the maximum value of x, well, this is when dx by dt equals 0. And dx by dt is the velocity. So we can work out the time when the velocity equals 0. So we'll substitute 0 into here to work out t. So 0 is equal to 20e to the negative 0.1t minus 10. We'll move this 10 to the left-hand side. So 10 will equal 20e to the negative 0.1t. Divide both sides by 20, so we get 1/2 e to the negative 0.1t. And then we'll take the natural log of both sides. So the natural log of 1/2 is equal to negative 0.1t. And to make the right-hand side simpler, I'm going to write that as negative t over 10. So now I can see I multiply both sides by negative 10. So t will equal negative 10 times the natural log of 1/2. And actually I can simplify this as well, because using the power rule, I can move this negative over to here, and this will give me the reciprocal of 1/2. So t will equal 10 times the natural log of 2. So now I've got the time for the maximum displacement, I need to work out the displacement function. So we know that v is dx by dt, and what we want to work out is x. So just like we did with the acceleration, if we integrate dx by dt, or integrate the velocity with respect to time, these two will cancel, and we've got the displacement. So x will equal the integral of a velocity. And we can work this out as the integral of this function. So 20e to the negative 0.1t minus 10. When we integrate this, again using the reverse chain rule, we'll multiply this 20 by the negative 10. So we'll get negative 200 e to the negative 0.1t. We'll integrate the negative 10, so it's negative 10x, and we'll add a constant. And again, if we go back to our boundary conditions, we know that x is 0 when t equals 0. So we can substitute these in. We get 0 is negative 200e to the 0 minus, this will become 0, so we'll plus the constant. We know e to the 0 is 1, so the constant will be equal to 200. So now we can substitute this 200 back into our displacement. So x will equal negative 200 e to the minus 0.1t minus 10x plus 200. And we know the maximum displacement is when t equals 10 log 2. So using our calculator, x will equal negative 200 times e to the minus 0.1 times t, which is 10 log 2, minus 10 lots of 10 log 2, plus 200. So this gives us a maximum displacement of 30.68 meters. Okay? Let's move on to question 2. Okay, so in question 2, we're told that a particle r is moving along a straight line. At time t seconds, the acceleration of a particle is given as this function, where t is greater than or equal to 1. So we're being given that v equals 0 when t equals 3, and shown that the velocity of a particle at time t is given by this equation here, where this constant here we need to find. So we're going to use a different approach with this question, but we know that the acceleration is still the rate of change of velocity with respect to time. So we can rewrite this as dv by dt is equal to 2t plus 4 over t times the velocity. And in a previous lesson, we learned how to solve differential equations like this using an integrating factor. We need to make it look of the form dv by dt plus pv is equal to q, where p and q are functions of time. So what we need to do is move this term to the left-hand side. So dv by dt minus 4 over t times v is equal to 2t. So now you can see that p is equal to negative 4 over t. So all I've done is I've found that this function here we can write as negative 4 over t. And then q will be equal to 2t. So I can use this value of p to work out our integrating factor. And this is when you raise e to the power of the integral of negative 4 over t with respect to t. So we covered all of this in a previous lesson on solving first order differential equations. So if you're not sure about that, it's worth having a look on my website. So the integral of negative 4 over t with respect to t will be equal to negative 4 times the natural log of t. And now using the power rule, we can move this negative 4 over to here. So this becomes the log, or the natural log, of t to the negative 4. So using the integrating factor, this becomes e to the ln of t to the 4, negative 4. These will cancel, so this gives us t to the power of negative 4. So this is our integrating factor here. Now we need to multiply everything in this differential equation by this integrating factor. So we get t to the negative 4 dv by dt minus t to the minus 4 over t times v is equal to 2t and then t to the negative 4. I'm just going to move this down so I have more space. And we'll tidy this up a little bit. Times t to the negative 4. Okay, so now we can tidy this up. We have t to the minus 4 dv by dt. We can collect these two together. So we get minus 4t to the minus 5 v. And this will cancel with one of them. So we get 2t to the minus 3. Now if you see, the derivative of this term is this term, and the derivative of v is dv by dt. So now we can use the reverse product rule. So d by dt of t to the minus 4 v is equal to 2t to the minus 3. We'll integrate both sides with respect to t to cancel this. So now we get t to the minus 4 v is equal to the integral of 2t to the minus 3 dt. So t to the minus 4 v, we'll add 1 to this power, we'll divide by the new power, so we get minus t to the minus 2 plus the constant term. At this point, I can use the boundary conditions to work out this constant. We're told that v equals 0 when t equals 3. The right hand side will become 0. This is equal to minus 3 to the power of negative 2 plus the constant. So 0 will equal negative 1/9 plus c. So c, the constant, will be 1/9. And now we can put this constant back into here. So we get v over t to the 4 is equal to negative 1 over t squared plus 1/9. We'll multiply both sides by t to the 4. So v will equal, this will become negative t squared. So then we get 1/9 times t to the 4. So if we go back to the original question, and if we write it in the same form, v will equal this term first, so 1/9 of t to the 4 minus t squared. So I hope that's given you a better idea on modelling with first order differential equations. If you did find that helpful, please like and subscribe, and you can download the full lesson from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.